Hello and good evening. Welcome to York Universe, the astronomy podcast, written and presented by the students, faculty, alumni, and friends of York University. You will now find us wherever podcasts are distributed. I'm Paul Mackin, one of your hosts this evening, and I'm joined by my colleague, Maheen Hamani. Tonight, we are broadcasting live from the Allan Carswell Observatory at the Keele campus at York University in Toronto, Ontario, Canada. York Universe broadcasts live every Monday at 9 p.m. local Toronto time, or currently 1 a.m. Tuesday Universal time. We run in concert with our online public viewing, or as we call it, the OPV, run by the observatory staff. And sorry to say, we have clouded skies this evening, which means they won't have live images, but we do have a plethora of archival images to share, and we'll be answering your questions in the simultaneous YouTube chat. To follow our live show or learn more about us, please visit yorku.ca/science/observatory and follow the link to our online public viewing chat on YouTube. For any questions or comments about past shows or future suggestions for topics, please email us at observe@yorku.ca. You can also connect with us on Instagram at Yorku Observatory. You can also connect with us at Allan I. Carswell Ob on Facebook. All of our programs are free, but if you'd like to make a donation, and we'd certainly appreciate that, please see our website at yorku.ca/science/observatory. We'll be monitoring the YouTube chat for questions and posting fun content throughout the show. How are you doing, Maheen?
I'm doing great. I am actually not as sad about the skies being cloudy because I'm one of those astronomers who also enjoys the rain. But I do hope that the skies clear up soon. How are you doing today?
I'm fine, other than a bit of a summer cold, but so if I cough a little bit, I do apologize. But yes, no, I'm fine. It's been a bit of a weird summer, of course, because actually I probably don't have a summer cold. I probably am suffering from the lingering forest fires in northern Ontario that have been dumping smoke on the city of Toronto, and I think of a few of us have permanent frogs in our throat right now. It's This has been a couple of years in a row, and it wasn't that way when I first moved to Canada a very, very long time ago. So I think, we definitely have a changing environment around us, but there have been some great nights for observing, and I'm hoping that we'll have more. In fact, I think we're going to be talking a bit about the night sky. Do you have any observing plans for the month ahead, Maheen?
Um, I am looking forward to the upcoming full moon. And other than that, it seems like you have a lot of new updates of the meteor shower coming up, so I should probably make some plans for those nights.
Well, I mean, August is sort of peak season for a couple of things. And as we head into August, there's always one thing on amateur astronomers' minds: the Perseid meteor shower. And we're already in them a bit. The Perseids last like several weeks, and this is when we pass Earth's orbit, takes us through the debris tail of a comet, which is orbiting, all those particles orbiting the sun as well. But peak nights are August 12th and 13th this year. And happy day, the new moon is August 12th. So let's talk about why that's important. To see meteors, you need the sky as dark as possible. So you need to get away from the city. You need to get up into the country. You need to get away from street lights. And all that is for nothing if the moon is in the sky. You really want the moon not in the sky. So the new moon is the day before or the first day of the peak, and that's a big deal. On any dark night under those conditions that I just described, you can see up to 7 meters an hour by just laying back in a deck chair in a dark sky and looking up. Having no moon is essential to that. You might get one an hour with the moon in the sky. But if the moon's not there, you're golden. So when we get into August, particularly around Perseid peak, though, the peak can go 50 or 100. In some cases, it's huge. It's 500 an hour. This is not one of those years. But 50 to 100 is a good count for this year. Now, the constellation of Perseus is also well suited for observation here in Canada. It's a northern constellation and easy to find. So we're going to do something called constellation hopping here. And the first thing you have to do is in the north sky, look for a W-shaped or an upside down M-shaped constellation. That's called Cassiopeia. And you look directly below the W. So assume it's a W. If it's an M, you look above. But if it's a W, you look down to spot a curved line of stars. And that's called the segment of Perseus. Look for the brightest star, which sits right beneath Cassiopeia, is easy to find and starting with. Now, that's where you're looking. And if you just look in that general direction, you are going to see meteors that night. Again, given that you're in the country, no lights, clear skies, everything else. Now, if you can't find the W, if you can't find Cassiopeia, then we go back a step further in our constellation hopping. You look for the Big Dipper. Now, almost everyone knows what the Big Dipper looks like, and a lot of people know that if you take the two stars at the end of the cup in the Big Dipper and go upward, and it's about 5 times the distance between those two stars. You draw an arc in the sky, you'll see a medium bright star, and that is the North Star. That is Polaris. Now, if you look, remember where Polaris is. In your mind's eye, remember it. Now, go back to the Big Dipper and look at the middle star in the handle, which is called Mizar. It's actually 2 stars, but that's a talk for another day. Look at that star and draw a line between it and the North Star and follow that line along, and you'll be pointing in the general direction of that W or M. And that's where you start to look for Perseus. Now, a couple of other things about Perseus in notes. If you have binoculars in a dark sky, you can also look for the Perseus double cluster, which are 2 groups of stars. They're in our galaxy, clustered together. And the names of these, you got to love astronomy names. NGC 689, which has roughly 4,700 solar masses of stars in it, and NGC 884, which weighs in at about 3,700 solar masses. They're biggish clusters. And they're both surrounded by an extensive sort of halo of stars, and a total mass of the complex is about 20,000 solar masses. So, these are young hot stars. And the site is beautiful in binoculars or telescope, although you can see them with the naked eye under the conditions I described earlier. Okay. Now, in the same area is the star of the show in August skies. It's actually 1 trillion stars, the Andromeda Galaxy. It's in the same general area. And I would suggest looking online for how to find it. Now, Andromeda is a large galaxy, larger than our own, and along with the Triangulum Galaxy, they are part of what we call the local group, which includes the place we call home, the Milky Way. Andromeda is nominally visible to the naked eye under good conditions, but it's very large and dispersed. In fact, it's 6 times larger than the full moon. So a better way to look for it is look in the right region and then look for its core in binoculars. And you'll see it's just a fuzzy area, oval area. And around it, if you keep looking, you're going to start to notice some structure. And of course, there's lots of online pictures of this. When you find it, you will love it. In terms of things closer to home, other than meteors, which are, of course, the particles are in our solar system, we can start to look at the planets. Now, Venus is approaching greatest elongation now. So what that means is it's the maximum distance it's going to get this orbit for us and them and Venus. It's a maximum distance from the sun as we'd see it at sunset. Okay, it's the elongation between it and the sun is the greatest. So what that means is on a clear night, and you can do this in the city, you can do this anywhere, go outside, look in the sun, look in the west after sunset, and you're going to see a very bright star, and that is Venus. Um, After the sun and the moon, Venus is the brightest naturally occurring regular object. Meteors can be brighter, and now, of course, satellites and things can be brighter as well. But Venus is a planet, and it's stunningly bright. And it's so bright and pretty. It was named after the goddess of love, but the Romans and the Greeks before them knew nothing about the conditions on Venus because it's actually a hellish place. But it is really pretty at night. Now, the other thing about Venus is that on August 14th or 15th, which is very close to greatest elongation, there's going to be a thin crescent moon, a waxing crescent moon. It's remember I mentioned that the new moon was on August 12th. Well, August 14th and 15th, you'll have a 2 day old moon, which is quite thin, really close to Venus as it reaches its furthest point away from the sun from our perspective. So this is going to be something very, very beautiful. And because all the moon and this are so bright, you can take a picture of it and your phone camera will probably get it. And it's very cool and you can share it with your friends. Now, another planet in the night sky, a little harder to see detail on, but you can see it with binoculars, is Saturn. So it's in the southeast during pre-dawn hours around 2 a.m. to sunrise. And that's when it's getting sort of highest above the horizon around sunrise. It's located in the constellation of Pisces, and it's kind of a yellowish bright star. It's nowhere near as bright as Venus. And it won't, if you look at it, it won't twinkle like stars twinkle, but planets generally don't. So you can look at it and sort of look for something yellowish that looks a little steadier than stars, and you probably found Saturn. And finally, in the first half of August, Mars will rise out of the morning twilight and will lie near the star Betelgeuse and the twin stars of Gemini and Castor, twin stars in Gemini, Castor and Pollux. Now, that's great. Mars is, I always find Mars a bit underwhelming because it's a small planet. It's closer, not as close as Venus, but it's closer. But it is in a telescope not that exciting to look at, but you can see it. It's got that ochre color, and you can say, I've seen Mars. It also won't twinkle. That's the good news of the story. The bad news, I guess, if depending on what you like and what you don't like, is that Betelgeuse is there. And Betelgeuse is in the constellation of Orion. And when you start to see Orion in the morning sky, it's an early sign in our night sky that winter is coming. And I'm not a winter guy, so I love taking pictures in Orion in the winter, just fantastic. But I I long to go somewhere warm at the same time. So that's our night sky. I mean, any of those things appeal to you, Maheen?
The only thing I can think of is that if you're interested in observing next month, you should probably get lots and lots of sleep the next few nights, so that you can stay up for all of these stars, the planets, the meteor showers. It's a very booked August. I'm really looking forward to the meteor showers though, because as you said, it's with the new moon, so it should be perfect conditions to
It
observe.
should be very good. I will say that the one thing I learned this a long time ago, a buddy of mine from university back in the 80s, Glenn, he and I used to go out and watch the Perseids every year. But the thing that people don't realize because it's August is, around 3 o'clock in the morning at night in August, it's cold. So dress for colder conditions because it'll drop down to 6 or 7 Celsius, and you don't really expect that, but it does. So, with that being said, time to move on to this week in space history and astronomy. And Maheen, you've got something to tell us about an astronomer and his birthday.
Yes, I do. So I've realized I enjoy giving birthday shout outs for space and astronomy history. So I'm going to be talking about an American astronomer. And his birthday is actually tomorrow. His name is Charles Dillon Perrine. who made noteworthy contributions to the field of astronomy, as we will be discussing today. So, born on July 28th, 1867, Charles graduated from high school in 1884 in Steubenville, Ohio. He was interested in astronomy and photography during this time, but since he could not afford a college education, within 2 years of high school graduation, he moved to Francisco, California, where he worked as a business secretary until 1893. And after this long time of working as a big business secretary, his interest in astronomy still persisted. And on January 1st, 1889, he volunteered to observe the solar eclipse as part of an event organized by the Lick Observatory and became acquainted with Edward Holden. By 1893, he was able to convince Holden, who he had acquainted with earlier, to employ him as a secretary for the Lick Observatory. And this is when his career in astronomy began. By 1895, he had already demonstrated his abilities enough to have been appointed as assistant astronomer while continuing to serve as the secretary on the side. He discovered the first of many comets he was credited with that year using the observatory's 12-inch Clark refractor telescope. 2 years later, he was given full-time responsibility as an assistant astronomer under James Keeler's assistantship. During this time, he expanded his observing skills on a 36-inch Crossley reflector telescope. However, unfortunately, eventually Keeler died and a new replacement, William Campbell, came into the picture. Campbell actually promoted Charles to the full astronomer status, and as an astronomer, he took over the responsibility of the Crossley telescope that we talked about earlier, which is 36-inch reflector telescope, and he made many modifications to this telescope and resolved the associated mechanical problems they were running into since the time of Keeler. So one such change that he made was placing the photographic plate holder inside the tube at the primary focus, eliminating light loss from one of the reflections. And the celestial photographs taken from Crossley following these modifications were excellent. Some of his major discoveries during this time were nine new comets, a recovery of four returning periodic comets, and the apparent superluminal motion of the expanding light bubble around Nova Persei. Nova Persei was initially mistaken for a nebula, but it appeared such due to light from the nova event. And as a reminder, nova event is something that happens when a star dies or it goes supernova. And this light that was emitted from this event was reflected from the surrounding interstellar medium as the light moved outward from the star. And so it kind of made it appear as though you're looking at a nebula, but really it was a supernova and this specific event that was happening. He studied this phenomenon in more depth using photographic, spectroscopic, and polarization techniques. He then discovered the sixth moon of Jupiter called Himalaya in 1904 and seventh moon called Elara in 1905. He also made observations of the 1901 minor planet Eros during opposition to measure Earth-Sun distance. And using this data, he published an estimate of solar parallax in 1904. Due to a flourishing career in astronomy, and as we saw, he made tons of discoveries, he was eventually appointed director of the Argentine National Observatory in Cordoba, Argentina in 1909, and he left the Lick Observatory during that time. His contributions to astronomy and its causes did not stop here. As the director, he continued a program of modernization of Cordoba's facilities for conventional astrometry. which is a branch of astronomy that focuses on precise measurements of the positions, movements, and distances of stars and other celestial bodies. Despite lacking an interest in astrometry itself as a subfield, he still, as a director, completed the publication of all of the observatory's astrometric observations in 16 volumes. One of his lasting contributions was the creation of the astrophysical station at Bosque Alegre, 50 kilometers southwest of Cordoba, which houses a 60-inch reflecting telescope. And his efforts resulted in Cordoba becoming the main astrophysical station in the southern hemisphere for a time between 1896 and 1947. This is also a time when he wrote more than 200 papers on a variety of astronomical topics. And from all of this work, he was honored by Santa Clara College, California, by being conferred an honorary DSc degree in the year 1905. So, from having started as a business secretary without any initial formal education in astronomy, he sure did make his mark in the field. And he did leave us with discoveries we are mesmerized by, or at least I am, to date.
That's a great story, and I've seen the Crossley telescope. Um, I think it's maybe the second largest refractor in the world. The Aix Observatory being the largest, I believe, which is 40 inch. That's 36 inch. But there's a great story about that observatory. So the guy who founded it wasn't an astronomer, but he did well and was interested in astronomy. Lick, his last name was Lick, and he donated 700. He was from Peru. He moved to California. He was a piano maker and a woodworker, and he left $700,000 to found the observatory. And I visited the observatory, saw the Crossley, and you can go to I don't think now you can do even any kind of tours there, but I was able to get a tour on the to see the Crossley telescope, but you couldn't get into the main dome, which is where the 150-inch Lick Observatory, the reflector is, and I'll get to that. That's an important telescope. I'll get to the reason why in a moment. But um, interestingly, uh, under the cross under the Crossley telescope, there's a plaque at the bottom, and it says, "Here lies the body of Lick." He's buried under the Crossley telescope is actually his gravestone, which is remarkable. And the story about the Lick Observatory is it's where a technique called adaptive optics was first developed. And I managed to talk myself into a private tour with the lead engineer, and it was fascinating. But it is a beautiful location. It's right in the mountains, about an hour's drive outside of San Jose. If ever anyone gets a chance to get down there, I don't know. I'm pretty sure the tours are canceled as of COVID, but boy, is it worth just driving up there and looking around. So that being said, this week my history story is not one story; it's two stories, two milestones, 362 years apart, and they both transformed how we explore the moon. Now, everyone knows that Galileo got a telescope and looked through the telescope, and he looked at the moon, and he looked at Venus, and he looked at Jupiter, and he looked at Saturn, and he documented these things. And on the moon, he saw mountains and craters and things like that. But what's not known is that Galileo wasn't the first person to do that. A few years beforehand, a guy named Thomas Harriot became the first person to draw the moon through a telescope. Now, 362 years later, on July 31st, 1964, Ranger 7 became the first spacecraft, American spacecraft, to photograph the moon up close. So, contrary to popular belief, the first person to map the moon wasn't Galileo. 4 months before Galileo published his famous observations, English astronomer Thomas Harriot sketched the moon through a telescope, producing the first telescopic lunar map. His work remained largely unpublished, so Galileo received most of the historical credit. Uh, on July 26, 1609, Harriot's drawing of the moon observation has been noted as the first recorded telescopic observation ever made, predating, Galileo's 30 November 1609 observation by almost 4 months. Galileo's drawing, which was were the first observations to be published, and they contained much greater detail, such as identifying previously unknown features, mountains and craters, and so on. In late 1610, Harriot inaccurately drew how far the crescent moon would be illuminated around its limb, and this inaccuracy led to, you know, he also missed how some craters were placed and did not draw details. So he got sort of poo-pooed for this, but he did use a 6 times Dutch telescope similar to the one that Galileo used. His drawings and descriptions were very simple with minimum detail, and they were considered difficult to analyze by later scientists, whereas Galileo's astronomical observations regarding the moon were published in a book in 1610, and Harriot's were published until 1784, with some not coming to light until 1965. But he continued his observations for the moon of the moon until 1612. Now, 362 years later, we had the Voyager program. Now, the Ranger program. The Ranger program was a bit of a disaster. It was a series of uncrewed space missions to the United States whose object was to obtain the first close-up images of the surface of the moon. And the way it was going to do this was simplicity itself. You build a rocket, you put a spacecraft on it, which is basically 2 solar wings, a radio dish at the back, a big long tube with a camera and a lens at the top, and the ability to take a picture, quickly scan the picture, and kind of fax it back to Earth. That was the technology that was used. Now, so and the idea was that the Ranger spacecraft would just keep getting closer to the moon until it crashed, and you take pictures up to the last possible moment. Um, so a series of mishaps, however, led to failure of the first 6 flights, and this led to, this almost ended the Jet Propulsion Laboratory. This was kind of their first big mission, but they came back from it. They got into better project management. They got through a whole bunch of the technical problems with transmitters failing and how to point at the moon and get there. So Ranger 7 launched on July 28th, 1864, and then achieved the first completely successful U.S. lunar mission impact. It transmitted over 4,300 high-resolution close-up photographs of the moon, and it sent them back to Earth before impact in Mare. I always hate these names. Latin's not my thing, but Cognitium. It was followed by Rangers 8, which went to the Sea of Tranquility, where eventually Armstrong and Alden landed, and Ranger 9. And these represented our first detailed maps of parts of the lunar surface. The Ranger mission was later followed by the Lunar Observer missions and the Unmanned Surveyor missions, which successfully landed on the moon. So, in 1 week, we had these two sort of bookends to our mapping of the moon. And I think that's just a marvelous little story.
Yes, it definitely is. And I think what I loved about your story was how you went from Harriet drawing the images from looking into the eyepiece to like sending a spacecraft which was destroyed upon
Yeah,
impact on the moon. And I'm like, okay, we just jumped like a lot of generations, it seems like. And it just
306.
shows how far
That's
we've
a
come.
hundred generations. 100 generations.
Yeah.
we, we did that in 100 generations. Now think about it, though. It took us 100 generations to go from Earth to the moon. in a sense. But since the time we've learned to fly, it was only 6 years, 60 years, less, just slightly over 60 years to put people on the moon. And from the time we've gone to the moon to the time we've gone to the very farthest edge of the solar system was only 50 years. So who knows what the next 40 years is going to bring us? We'll see.
Yeah. Yeah, I mean, I just kind of thought about people 200 years from now or even 40 years from now, just thinking about what we're doing now, similar to how we're thinking about people looking through the telescopes from an eyepiece. And I don't know how much more advanced can we get from here that that's kind of the similar nature of what they're looking at our current technological development. I don't know if we can go, you know, to way more capacity of, technological advancement, but I don't know what that's
Yeah.
going to look like. Yeah.
Well, I think that there are some hard and fast rules. The speed of light seems to be pretty much a speed limit, and the amount of energy it takes to get there is probably pretty difficult to find. But what I would say is there's a lot of room between where we are now and that speed limit. So let's see
Mhm.
where we can get to.
Yes.
Um, so we're halfway through our time. And so it's time for some reminders. You are listening to York Universe, the space and astronomy podcast from York University. We are broadcasting live from the Allan Carswell Observatory at York's Keele campus in Toronto, Ontario, Canada. Please look at our website, yorku.ca/science/observatory, to join the chat, which is live on YouTube as we speak. If you have questions or want to see some other content, you can always send us a message there as well. Tonight you're talking to I've got the name's name here. Mahid Ahmadi and Paul Mackin as your hosts. A couple of announcements. Astro Fair is on August 29th. The tickets are $30. Now, this is a full day astronomy planned by the observatory and its partners to bring you access to booths, activities, telescopes, a planetarium. We don't have a planetarium in Toronto anymore. Um, Visitors will have the opportunity to walk through the solar system, investigate sundials, engage in a whole bunch of science-based activities all in one ticket. Um, Now, we also do have, normally at this time of year, our atrium tours, but there's some construction going on in the garage where the atrium's on top of, so they're um, on pause now. We are organizing pop-up observing through the events through the next month, and information can be found on our social media feed. So, with that being said, let's get into the second half of our game here. Maheen, talk to me about China's burgeoning space program.
Yeah, so for today's first space news item, I decided that we talk about NASA a bit too much, so we should look around the globe and see what else is going on. So in March 2024, China launched its mission to the far side of the moon called Chang'e 6. And it successfully brought back the first samples from the far side, and it has already provided us with scientifically valuable clues about the moon's surface as it relates to receiving solar winds, which is, if you don't know what solar winds are, they are a constant stream of charged particles, which are emitted by the sun. Recent studies that conducted sample analyses provided evidence that the near and the far sides of the moon have not experienced the bombardment by the solar wind over billions of years in the same way, which means that particles striking each side, it was found that they arrive at different speeds and they carry different amounts of energy, which I think is quite interesting. Um, so, unlike Earth, the moon lacks a thick atmosphere or a global magnetic field. So, fast-moving charged particles strike its surface directly. And the impact of this is stored in the lunar regolith. which is the surface layer on the moon, and you can think of it as the lunar soil, which is not the same or even similar to Earth's soil, um, but it's sort of a good way of imagining what we're talking about. So this contains volatile materials, including noble gases, as delivered by the solar wind. And since noble gases rarely react chemically with other elements, that's like the nature of these elements, the noble gases, they serve as reliable markers of the way in which solar wind particles entered and accumulated in lunar soil. So, until recently, scientists have been unable to compare the impact of solar wind strikes on the two sides of the moon because we didn't have a sample from the far side. And this changed with Chang'e 6's return of the lunar sample from the far side. A sample analysis of lunar regolith from this far side was conducted by a team led by Institute of Geology and Geophysics of the Chinese Academy of Sciences. They examined the concentrations and isotropic compositions of helium, neon, krypton, argon, and xenon in the regolith. So these are all elements associated with what is known as the noble gases. And what they found was a clear difference in the neon isotopes, which are essentially two different forms of neon. So when we think of isotopes, we're basically talking about um, the same element, but with different atomic masses. So one has an atomic mass of 20 and the other has an atomic mass of 22. So the number of neutrons within the atom is different and it has the same number of protons. It was found that the ratio of neon 20 and neon 22 was considerably lower than all near side samples that were previously studied. The ratio did, however, closely match the theoretical composition that was expected after strong solar wind fractionation, where fractionation refers to the change of an element's abundance between the sun and the solar wind. This suggests that the far side experienced more intense isotopic fractionation, which caused neon 22, the heavier element, to become more abundant, which caused, of course, the ratio of 20 over 22 to be smaller. Additionally, it was found that the two hemispheres received particles with different energies. So, this was found in stepwise heating experiments, where xenon was only released from the material mainly at high temperatures in comparison to the material from the near side, which they received from Chang'e 5's mission. And the material from the near side released xenon at both low and high temperatures, whereas the one from the far side only released it at high temperatures. So this suggests that the solar wind must have penetrated farther into the regolith on the far side, which generally requires faster energy particles, implying higher energy solar wind exposure on the far side of the moon. So the explanation for this difference in speed and energy of solar winds is in the impact of Earth's magnetosphere and this whole system of Earth, Sun, and Moon. So when the moon travels around the Earth, it sometimes passes the buffer region surrounding the magnetosphere, and this is known as the magnetosheath, where the solar wind slows from its usual speed of about 400 kilometers per second to 200 kilometers per second. And this reduction of speed is mainly experienced by the moon's near side, which is facing the Earth. Due to low energy of particles, they do not travel too deep into the surface and remain only on the top of lunar regolith, as was found from the material analysis of the near side. The far side, on the other hand, remains exposed to undisturbed solar winds. So from the far side sample, we now have direct physical evidence of Earth's magnetosphere controlling the speed of solar wind particles reaching different sides, or the near and the far sides of the moon. And this is recorded in the depth at which particles entered the regolith and the isotopic composition of the noble gases trapped. And this provides us a glimpse into the complexity of the relationship between the Earth, the Sun, and the Moon, and how such samples can provide deeper insights into their history.
Sorry, I lost you there for a sec. Yeah. So a couple of interesting things about China's space program. First of all, there's a really interesting uh, Welsh reporter, Andrew Jones, and he is famous for his specialized reporting on China's space program. And if ever he's actually based out of Finland. He also contributes at the Planetary Society on their regular weekly podcast as well. But uh, China is doing things that no one's ever thought of before. Putting a satellite, landing a probe on the far side of the moon and having it return samples. You got to put a satellite, the one you just talked about, out in space so that it can act as a communications link to Earth, but it can also do science. They are the first space agency, and they're doing this right now as we speak, to visit a quasi moon. This is something that's sort of in a similar Earth orbit to the Earth, and they've sent pictures back of that. The one they're visiting is actually very likely a chunk of the moon blown off. But China is doing some amazing things. I mean, NASA's great, but they're not alone anymore. NASA's doing great things. JAXA's doing great things, the Japanese Space Agency. The Chinese National Space Agency is doing great things. Indian Space Agency is doing great things. There's several Middle Eastern space agencies that are starting to do some amazing things. Canada's going to get there. We're now building launch facilities. We were the third nation on Earth to put a satellite in orbit. So, it's not just a story of NASA anymore, as great as NASA is. Uh, but hats off to the Chinese. That's very exciting science. That
Yeah.
being said, though, sorry, go ahead,
Yeah, I was
Amin.
just gonna say, I mean, on the topic of, global space, space missions and things that are going on globally for different countries. I wish that the pursuit of science, or I guess we could say that a lot of the space stuff is not always about science, but I wish it was, you know, technology and science, but also not as political as it can get. Um, but I wish that people kind of collaborated more than they're currently doing instead of, turning it into like some kind of a space race where it just isn't beneficial to us as humanity in general. So like that just came to mind when you said, okay, NASA is no longer alone, but I wish there was more collaboration than there currently is.
Yeah, and I mean, there is in places, right? NASA and the Europeans play very well together, do a lot of joint
Hmm.
missions. NASA and the Japanese do a lot of joint missions, right? Um, the Chinese Space Agency is a little more on its own, but it collaborates. The Russian Space Agency, I mean, the Russian Space Agency, and all due respect to Russia because they got there first, but they don't do a lot of exploration missions anymore. They basically provide a taxi service to and from the International Space Station, and they provide crews. But their focus is very much not on exploration missions. They keep announcing them, and they don't generally happen. So it's sort of a bit of a changing landscape. And again, I have to be a little careful what I say about Russians because I'm married to a Russian, so who likes the Russian space program. But speaking of NASA, though, they did just release a spectacular time lapse image or video from their spacecraft Psyches may fly by of the planet Mars, which provided a gravity assist um, for the spacecraft on the way to the asteroid Psyche. So just to be very clear, there's a spacecraft called Psyche. It is going to the asteroid called Psyche. All right. And Psyche's a really interesting place, but the spacecraft during this encounter, it passed within about 4,600 kilometers of Mars, and it increased its velocity by roughly 1,600 kilometers an hour doing that. So basically, as it gets closer and closer, it's accelerated by Mars's gravity. And then as Mars moves away, it retains some of that momentum and gains some momentum rather, and the planet Mars itself actually loses some momentum. But since Mars is so much more massive, yeah, you're never going to notice on Mars, but the spacecraft notices. And doing this, it was able to test and calibrate all of its science instruments. It recorded its first magnetic field measurements in space, and that's really important because we'll talk about Psyche's mission in a minute. And it photographed both Phobos and Deimos, which are Mars's moons. Now, what makes the story interesting is where it's going. Unlike every asteroid we visited before, 16 Psyche is metallic. Now, in my home office, and I can just sort of see it from where I'm sitting right now, I've got a little nickel iron meteorite, and you can buy these. They're available from a number of different services. You can look online, but it is not a rock meteorite. It's a metal meteorite, which tells us there's metal meteorites. They're metal meteorites. Well, what Psyche may be is an entire asteroid which is highly metallic. There's a theory that Psyche was the core of a planet which failed to form. So as this planet was starting to form, the temperature would go up in the core, it would liquefy, and the metal would move to the center. And I'm not a geophysicist, but I guess I could play one on podcasts. And that metal moved to the center, and then for some reason the planet failed. And There's many different explanations of this, including the last episode of Star Trek Strange New Worlds, which provided a really interesting explanation for why this happened. But suddenly you've got this planet that failed, and the core is left floating in space, and it's mostly metal. And Psyche, when we look at it, has the spectral characteristics and several other characteristics, density and so on, that indicate that it may be highly metallic. So if this hypothesis is correct, Psyche could be our first direct look at a material similar to Earth's core, something impossible to study on the Earth. And this is a very ambitious mission. It's the first mission with kind of implicit financial and resource focus. Think about it. If it's got a metal core, could you mine that? It's in the asteroid belt. It's not that far away. Could you return material to Earth sometime? Could that mean that we could get certain resources from there that we couldn't get as easily on Earth? Don't know, but there's some thought on that. It's also an ion thruster spacecraft, and what I mean by that is most spacecrafts, they burn all their propellant near the beginning of the mission. They reserve a little to slow down or to change course or whatever. So they have an initial very big change in velocity called delta V. And then they sort of coast. The joke is that Isaac Newton is responsible for getting them there. But an ion spacecraft does something quite different. Yes, it gets going and it uses rocket fuel to get there. But once it's going, it can fire an ion engine, which basically electrifies a gas like xenon and basically turns it into a plasma, which is ejected out the exhaust of the spacecraft, and it produces a very small amount of thrust. Kind of think of the weight of a piece of paper on your hand, but it can do that continuously for years. And that's what this does. So you build up an enormous change in velocity, but it takes you a long time to do it. It's also very good for slowing down the same way. So this spacecraft isn't going to get to Psyche until 2029, uh, but Psyche could be key to understanding the formation of the planets in the early solar system. And I'll leave you with this thought. We're not sending a spacecraft to an asteroid. We may be sending it to the exposed heart of a failed planet. And when I say that, and I think that, science isn't romantic as any other human endeavor. It really is.
Wow, that's so interesting. Do you know if they're going to be able to collect samples from the iron core?
I'm sorry?
Do you know if they're going to be able to collect like a sample from?
No, it's not. It's an orbital mission all. But remember, I mentioned that it was able to measure Mars's magnetic field.
Mm-hmm.
That's key because a metal asteroid will have specific magnetic characteristics, and so we're going to be able to get a lot of data. It's got an X-ray spectrometer. It's got a magnetic field instrument. It's a fascinating mission. This is kind of my favorite asteroid mission ever. Although Lucy is a close second, but. And we've talked about Lucy on other occasions, but this is a fascinating mission.
Yeah, we'll definitely learn more about Earth in the process.
Yeah. And if anyone wants a real hint as to how that planet didn't form, watch last week's episode of Star Trek Strange New Worlds because it covers it and it's quite fun. So Maheen, you've got something about an astronaut.
Yes, I do. So, again have another story which is also related to a NASA astronaut. So, NASA's astronaut Chris Williams returned to Earth yesterday on January 26th, not January 26th, I'm sorry, July 26th, after an eight-month science mission at the International Space Station, or the ISS, marking his first mission. He completed 3,856 orbits of Earth and traveled more than 102 million miles. While on the ISS, he contributed to numerous scientific studies and technology demonstrations. This included research with the potential to support new developments in cancer treatment and aiding the investigation of ways to improve the production of material in space, which can be used for high performance computers and electronics. So if you're wondering was he working towards cancer treatment in space and how does that any of that make any sense? Essentially for cancer treatment support, Chris Williams worked with ESA astronaut Sophie Edenot to process DNA-inspired materials with the potential to advance new cancer treatments for us, of course, on Earth. These materials are designed to be made in space so that they can form more evenly and consistently due to microgravity, which improves their performance and their readiness for treatments here on Earth. On the technological improvement side of things, he grew semiconductor crystals, which can also be grown to the desired size and in larger amounts in space due to, again, microgravity. This is helpful because research has shown increased performance of computers, AI, and medical devices from space-grown crystals. And this is why they're doing this over on the International Space Station. Williams also conducted two spacewalks during his mission. One was to prepare the station for upgrades to its electrical power system. And to do this, he prepared an orbiting laboratory to which new solar arrays will be added in a future spacewalk. Once this is done, the final set of ISS rollout solar arrays will complete the full suite of additional solar power and will increase ISS's power generation by 30%, enhancing support for daily operations and, of course, scientific research. The other spacewalk that he conducted was to replace a faulty joint on the Canada Arm 2 robotic arm. I guess shout out to Canada, which captures cargo spacecraft and deploys external research systems. So it's like an arm in the space, not like ours, but kind of like ours. We're not going to the robotics of Canada Arm 2, but essentially it was to do some fixes on the faulty joint of the arm. And such research and maintenance work, of course, is essential for future space exploration missions and other kinds of experiments that are being conducted on the International Space Station. And now that he is back, which was yesterday on July 26th, after completing medical evaluations at the landing site, he will travel with other crew to Kazakhstan. This is where the recovery teams are stationed, and then he will fly back to the Johnson Space Center on NASA's aircraft. This also seems like the right time to mention that it has now been more than 25 years of sustained astronaut presence at the International Space Station. It is a lab in space that allows us to conduct experiments and pursue scientific questions that may be difficult to explore under Earth's conditions. And as we recognize this from the cancer treatment and technological improvement efforts of Chris Williams in space earlier. Another such example is space medicine, which allows us to study the impact of space travel on humans and develop solutions for extended human spaceflight missions, all of which is essential for our future space exploration goals to the moon, Mars, and beyond that we have.
Yeah, this is it's hard to believe the space station is 25 years old, and apparently it is getting a little long in the tooth. But NASA and the Russians just basically agreed, and the ESA partners in Canada just agreed to extend its life for another a couple of years out to no earlier than 2030. I my guess is it'll go a little longer than that. And SpaceX, along with a company called Avast, are looking to launch the first module of the Avast space station, which is considered to be a replacement from the NASA point of view. But we'll see how that goes, because when new technology deploys, it can be a little tricky, and that's a very good lead into our very quick last story, because we're almost out of time, which was I think on Friday, Starship 13 launched, which is SpaceX's new mega rocket, and this is a big deal because this is one of the systems selected by NASA as a lander system for the return to the moon. So there was an initial attempt to launch this on July 16th, but the vehicle software triggered an automatic abort at exactly T minus zero. So, the engines lit and then they immediately shut off because six of the Raptor engines, and hold on to this thought, had problems with their turbo pumps and the oxidizer wasn't coming in. And long story short, basically six of the engines didn't start. So then they had another scrub. So they pulled it and replaced those engines. Then they tried on the 24th, and that was a weather scrub. So they didn't launch that day. But then the third attempt was July 24th, and it was successful. And it was the first Starship mission to deploy satellites. We'll talk more about that in a second. Operational satellites. Now, so there's two parts to this system. There is the booster 20 in this case, and Starship. And the Starship had a great mission. It went up, it blasted out at 20 operational Starlink V3 satellites. There's some great video online of the satellites taking pictures of the spaceship as it moves and then goes back down into the atmosphere and so on. It relit one of the engines, which is critical for deorbiting exercises and so on. But then when Booster 20 was coming back down, it was going to try and do a controlled landing in the ocean. Only 10 of the Raptor engines relit, and that's been a continuous problem with Booster. And two of these shut off within seconds, and so it impacted the ocean at a way off course at about 100 kilometers an hour. So it was a hard splashdown and an explosion. But so, to summarize, that we had continuing motion with the Raptors on the booster not relighting, the successful deployment of 20 Starlink V3 satellites. And I would encourage our listeners to go online and look for some of the footage they shot, because four of them had cameras. Spaceship landed softly and intact in the Indian Ocean. Normally, when Starship lands, it breaks apart and explodes. This time, it just went into the ocean, landed, nothing broke. It was great. So this is a possible layup for the first single orbit mission, with the chopsticks capture of Starship back at the launch site. And the launch of the next mission, Mission 14, is tentatively scheduled for August of this year. And with that, we're exactly on time. So it's time to wrap up our podcast for this evening. I want to thank everyone for joining us tonight. You've been listening to York Universe, the astronomy and astrophysics podcast, written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been the mighty Maheen Hamani and me, Paul Mackin. This podcast and past episodes are available wherever podcasts are distributed. You can always connect with us on Instagram at York U Observatory. You can also check us out on Facebook, at Instagram, at Allan I. Carswell Ob. Our website is yorku.ca/science/observatory. And there we have a lot of interesting content. And it's also got a link that you can select if you're so inclined. And it's a great place to make a Canadian tax-deductible donation to our student-operated, not-for-profit observatory. So on behalf of Maheen and I, thank you for tuning in this week. We wish you clear skies and a great evening.
Have a good night.